correct? That's 213, right? Okay. So what this is saying is you've got a negative I, all of this is to the 213. You know there's a 1 right here, right? So this is really negative 1 times I to the 213th power. So what you're doing is you're raising both of these to the 213th power. So what is negative 1? If you were to take negative 1 and multiply it 213 times, in I times 200, multiplied by itself 213 times, let's deal with this. This is going to be a 1 or a negative 1. It's going to be a negative 1 if the power is odd. It's going to be a 1 if it's even, right? So this whole thing goes to what? Negative 1. So we can get rid of that. Just bring it down. Now let's mess with this piece. This piece, we're going to rewrite it as I squared. How many times does 2 go into 213? 106 times. Any left over? If you're going to have anything left over, it'll be just an I. You guys with me? Now, what's another name for I squared? Negative 1. And a negative 1, whoops, to an even power is what? This is going to be a positive 1. And don't forget you have your negative 1 here. So what you have here is this is a 1, negative 1 times 1 times I. All of this is just negative I. You get that? Can you any others done?
We could have just taken off the 213 exponent.
For that one, but can you do it for the other ones?
I don't know.
Any other ones you want me to do? 51.
Yeah, that one.
51. Ah, 51. Okay, first rewrite this as 2 plus root 5I and 1 minus root 10I. So far, so good? Now FOIL. 2 times 1 is 2. And then we're going to have negative 2 root 10I. And this is going to be root 5I. And then this times this is going to be negative. And then, do you know how to multiply? This is old stuff. What's root 5 times root 10? So you have root 5 times root 10. You know what that simplifies to be? You take, see this is 5 times 2. You're going to pull the 5 out. It's 5 root 2. That's like review from algebra 2. And then you have I squared. But what's another name for I squared? This is a negative 1, so you're going to make this a 5 root 2. This is negative 1. Negative 1 times negative 5 is positive 5. And I think that's all you can do. Just bring everything down. This is just not a pretty answer. That's it. You can't add these up because these radicals are not the same. If they were, you could. What else? These answers are in the back of your book. I don't think I should have to read them, read the answers to you. I hope you're checking them as you're going along to see if you're on the right track. Does anyone want me to do any other ones? Yes.
Number 7.
Number 7. This one's a subtraction one. So we're gonna get rid of these, parentheses. I would just write this answer as, see, these two are like terms and actually have the same denominator. So I would write root 2 minus root 3 over 2 and then plus 2i. Just leave it like that. What else? Anybody for 32, 30, 31, 32, 30, yes,
33.
sure. 33. Okay. First of all, can we add these two up?
No, without a common denominator.
Not without a common denominator, thank you. What's your common denominator? It's 1 minus I, 1 plus 2i. I'm not writing this very nicely. Actually, I'm gonna do it on a separate sheet of paper so I can write it 3 times. So you have 2 plus I, and I like to put parentheses around everything. Okay, that's your original problem. Now what you're gonna do is your common denominator is 1 minus I, 1 plus 2i, 1 minus I, 1 plus 2i. One of these will be on your test. It's a doozy. So what you have to do is go back now. You want to make this fraction equivalent to something with 1 minus I and 1 plus 2i. So what's missing over here? What do we need to multiply? And remember, whatever you do to the bottom, you have to do to the top to keep it balanced. You're actually not trying to change this fraction, but alter its appearance so that you can add these two up. So if you have the 1 minus I, what you need is the 1 plus 2i, which means what's fair is fair, you gotta do it to this right here. Okay? So our game plan is we're gonna distribute this 2 plus I to 1 plus 2i. What do you get when you do that? 2 times 1 is 2. 2 times 2i is 4i plus 1i. Can you just do that in our head, guys? Alright. And then what's I times 2i? 2i squared, which is, isn't it negative 2? Okay, so that's that side. This side over here, we had the 1 plus 2i, we were needing 1 minus I. Well, that's easy. What's 1 times 1 minus I? 1 minus I. Now let's clean up. Our numerator, we can add right across. I see right away those cancel. And what we have up here is 1 plus 4i. So my numerator is 1 plus 4i. The denominator, we need to start FOILing this. So what we're gonna do is FOIL. What's 1 times 1 is 1. 1 times 2i is 2i minus 1i is 1i. Watch your 1's and your i's. And then this is gonna give you a negative 2i squared, which is really 2. Yes,
Go back to that second term there.
yes.
How do we get that again?
This is a plus, my bad.
Cool.
1 times 2 is 2 minus 1 is 1, not a negative. Let me say it again. 1 times 1 is 1. 1 times 2 is 2 minus 1 is positive 1, not a negative 2. That was my mistake. And then these two multiply to give you a negative 2i squared. Negative 2i squared is really a positive 2. Remember, I squared is negative 1. Negative 1 times negative 2 is positive 2. Now clean this up. You've got 3 right here. So you've got 1 plus 4i over 3 plus I. Forget the 1 in front of I. Is this answer the right answer? It's right if you don't have to rationalize, but we always rationalize our denominator. So what do we do next? So at this point, I would give you points. If you got to this point correctly, I'd give you points. There's a chance you may make a math error somewhere along the line here. And let's say you had 1 minus 4i, for example. You know you're doomed. If this answer's wrong, you can't rationalize this correctly. But if I can read your work, and if I can follow your steps, and you take your wrong answer, and you rationalize it correctly, and I'll say that again, I can read your work and follow your steps, you're gonna get points, major points. So if you made this question might be worth like 6, 7 points. And if I find one error that you made, if I say, oh, I see it, they multiplied, like I just did, I made a simple math error at the beginning. But if I carry that error through, I will only take 1 point off. And if it's worth 6, I give you 5. But as long as I can read, if I have to sit there and look for, if it looks like a maze, I can't do it. Because a lot of people do this. This is why I draw arrows. I say, okay, this goes now, I'm gonna go here. So 3 times 1 is 3. I'm foiling now. You've got a negative I, and then this is 12i. Isn't that 11i? And then this is gonna be negative 4i squared, which is 4. And I'll do the bottom 2 now. 3 times 3 is 9. The beauty of the bottom here is that the next 2 cancel out. That's why you do the conjugate. And then I times I is I squared, but it's a negative I squared, which is really plus 1. Clean this up. We get 7 plus 11i over 10. Done. Can we simplify it anymore? No. The book may write for an answer, or at some other point in your life, you may see this answer, like on the ACT, it might be written like that. Okay? Questions, anybody? Anybody? No? Okay, I want you to go to the back. We did not finish these ones, but you're gonna have a chance to finish these tonight, and then I have more homework for you guys to do. But 59, 61, 63, and 65 are just the quadratic equation. This is nothing new. The only thing different is you may see a negative under the radical. Right? What am I doing? Writing the quadratic formula. I write it over and over and over. So what's the opposite of negative 2? 2. Negative 2 squared is 4. Minus 4 times 3 times 5. All over 2 times 3, which is 6. Now just clean this up. That's all you have to do. Now I've got 4 minus, this is gonna give you 12, right? What's 12 times 5? It's 60. And then simplify. Can you simplify 56? How do you break 56 up? Let's see. 2 and 28. 2 and 14. And 2 and 7. Did I do that right? So I could simplify this as 2 plus or minus 2 root 14i over 6. And I'm going to, that's just how I do it, you can do it whatever way you want. And now what's your best answer for this one? The twos, you gotta take these twos out, so your answer would be 1 plus or minus root 14I over 3. Don't forget that 1 right here. I reduced both of these by 2 and took a 2 out of here. Okay. I see a lot of people will forget this 1 and they'll write plus, they think it's a 0. It's a 1. Alright, now go to example 8. Because, see this, it says find all solutions. And what you have to do here is always get a 0 right here. You get x cubed minus 1 equals 0. Do you guys remember what this is called and what this is called? These two problems, what they're called? It's the sum or difference of two perfect cubes. See, this is x, 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 and this is 1, 1, 1. And this one is, x, 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 and this is 2, 2, 2. When you have two terms and they're both cubes, this can be a minus or it could be a plus. Do you guys remember how to factor this? You get a binomial and you get a trinomial. You're going to put one of each of these in here. Whatever sign this is goes there. And then you square, these two are x squared. Multiply these two together and it changed the sign. And then this is always a plus sign and a 1. So what you have here, this is going to be a real 0, x is 1, and then you're not going to like this, but you're going to have to use the quadratic formula to find these two imaginary zeros. So for this one, how do you factor this one? It's going to be x minus 2. So one of your zeros is 2. And then the other 2, you got to do x squared plus, this is going to be 2x, and then plus 4. So one of your zeros is 2, and then this one you're going to do the quadratic. Actually, you could complete the square. Probably completing the square might be easier here. So how do you solve this one? You're going to bring 4 over here, make it negative 4. Half of this is 1 and square it. We're going to add 1 to both sides. You get x plus 1 quantity squared equals negative 3. Square root of both sides. You get x plus 1 is plus or minus root 3I, and then subtract 1. This question, a lot of people get wrong on the test. Because I don't know if it's, you just don't know how to factor the difference or sum of two perfect cubes. So we're going to do one more. How do you do? How do you factor this one? X plus 3. Then what? X squared. Change the sign. Multiply these two, 3x. And this is always plus, always a plus sign here. And those last two. Remember this? So what would 27x cubed minus 100? 1,000. What are these? What's this? 3x, 3x, 3x. 10, 10, 10. So what do you get? You're going to get 3x minus 10. So what's one of your zeros? It's 10/3. Multiply 2 of these, you get 9x squared. Change the sign. Multiply these two together. 30x. And then this is always a plus sign. So one of your answers is 10/3. And then this one, what you're going to do is use the quadratic formula. Figure that out. Okay? questions. And this last one, this is an easy one, you guys. This is the difference of two perfect squares. How do you do this one? Go ahead, Jordan. What are these two answers right here? Which is 1 and -1, right? What about these two?
X equals plus or minus imaginary.
Good job. Okay, today, we're gonna do 4, 6.
Yeah, sure. The 3 questions.
What?
Okay, does everybody have the notes?
What? No.
Okay, now what we're gonna do is look at, whoops, sorry. We're gonna take, zeros, and we're going to write the function. I'm gonna go the other way. If I give you a 0, I wanna see if you can come up with the answer, the function. Alright, so, keep this in mind, please don't forget this. And I told you this yesterday, for every complex, what's a complex 0? Give me an example of a complex 0. 2 minus 4i. I can guarantee you, if 2 minus 4i is a solution, 2 plus 4i will also be a solution, for sure. Not sometimes, maybe. Complex solutions come in conjugate pairs. They always come in pairs. Always, 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 always. So now, can you keep that in mind? You're going to be asked to do 2 different things. You're going to be asked to find a polynomial or find the polynomial. A polynomial is an open-ended question, meaning the a value, you know when you write a function, goes like this, f of x equals the a value, and then it goes x minus, and then these are your zeros. That number is your leading coefficient. That a value, if it says find a polynomial, I could make that a value whatever I want. But there's going to be situations where they want the polynomial, where I give you a specific x and y value. So in other words, when you see f of 0 is 2, you better have the right a value. There is only one a value, you have to find it. So that's the difference between those two kinds of problems. If I say find a polynomial, you don't need to worry about the a value. You can put whatever you want. We'll just be simple and say 1, okay? So, what do you do in this case right here? If I tell you to find a polynomial, and I say the degree is 4, and I tell you 2 of the zeros are 3i and -3i, what are you gonna do? You're gonna start off with this little recipe here. What do you notice the same?
both are.
They're both negatives right here. Now what you're gonna put here is 3i, and you're gonna put negative 3i.
You should just left that out.
You could have for this one. You could have for this one. Can we simplify this? Like Jordan said, couldn't we have just left that out? Yeah, for this one you can. But they are going, and we're gonna even skip the a value, who cares, because it's saying I could put whatever, I could put 2 here. But we're gonna make it easy on ourselves and say 1. So can I just drop the parentheses here, because this looks really confusing with double sets of parentheses, and I could say x plus 3i. Are you guys good so far? What's wrong with this problem? What degree did I say it had to be? 4. Do I have 4th degree right now? What do I have? I have 2. So how can I make this a 4th degree? I can square both of these, right? Now the problem is they don't want you to leave your answer like this. I want the polynomial. I want it in that factor, like in standard form. So for you to take this problem and factor it completely, if you were to take x minus 3i and x minus 3i, and then x plus 3i and x plus 3i, it's gonna be a mess. But you could do something. Make it easy. Which 2? Aha, Jordan saw it. If you take, because of the commutative property for multiplication, we can switch these around. It doesn't matter what order we multiply them, right? I can take these 2 and multiply them together first. Why, Jordan, did you want to do that? What's going to happen when I take this one and multiply them together? Well, he noticed that these 2 signs are opposite. And what happens when you do this? The next 2 cancel out. So what do you have here? When you FOIL this out, you have x squared. What's the last 2 going to give you? What's negative 3i times 3i? Isn't it 9? Isn't it 9? Negative 3i times 3i is negative 9i squared, which is 9. Well, all we did was we multiplied these 2 together. Well, aren't these 2 going to give us the same thing? Right. So now if I took these 2 and multiplied them, I'm smart, I can see it's the same thing. It's going to be x squared plus 9, right? Now how much, that's a lot, isn't it easier to do this? We can FOIL this out. What's x squared times x squared? And now can we do these next 2 in our head? 18x squared and 9 times 9 is 81. So our answer is this. Now, if I happen to give you, let's say I said f of x, if I said f of 0 is 1. If I gave you this piece of information, what you would have to do is take this and put an a value in front. You're going to plug 0 in for x, 1 in for y. You have to find the a value and then put that a value back in. But they didn't give you that. So you're done with this answer. It's done. Okay, you leave it just like f of x equals x to the 4th plus 18x squared plus 81. But this next one, I want a specific polynomial that has an a value of something. What is it? Well, what do you get? Let's read this out. It says degree of 3, and they give you the zeros. So how are we going to write this? F of x equals some a value, and then we've got, can I just write it like this, x plus 1? You know it's negative 1. X minus a half, and you know it's positive 1/2. And x minus 2. Positive 2. Now, if I said find a polynomial, degree of 3 and those zeros, I would be done with this answer. But they threw this piece in for you. I wanna know what the A value is, so what you have to do is put, for X, you're gonna put a 0, and for Y, you're gonna put a 2. So you're gonna put 0 here. And 2 right here. Cause guess what we're looking for? A. What do you get for A? Negative 1/2 times negative 2 is 1. 1 times 1 is 1. So A is 2. So at this point, all I want you to do is this is what your answer would be. And we're gonna leave it for this, like this for now. If they want you to write the polynomial in standard form, you're gonna have to FOIL it. However you want, some people will take this 2 and distribute it here, so they'll write 2x plus 2, and then FOIL. I'm not gonna mess around with FOILings right now. You guys know how to do that from freshman year. Let's keep going. Back side. Okay, number 3 says find a polynomial. Who cares what the a value is on this one? We don't care. But I want it to be a degree of 2. And I give you only one of these complex zeros. So what did I tell you? If 1 plus 3i is a 0, you can't have it unless you have 1 minus 3i. Just because I didn't write it doesn't mean that it's not there. It's there. So now, what are you going to do? You're going to write f of x, and Jordan, this is why you need to do this this part right here. Remember how I did that? This is why this is important, a good habit to get into, because of these kinds of solutions. This one here, 1 minus 3i and 1 plus 3i. Now, for you to FOIL this would be a disaster. I'm going to make it easy again for you. What you're going to do is simplify this by distributing the negative here. You're going to write x minus 1 plus 3i, and you're going to write x minus 1 minus 3i. Our goal is to make this simple to factor, and we can by regrouping, putting parentheses, you're shifting the parentheses to these two. Because now when I FOIL, I've got the difference of 2 perfect squares. So what you're going to do is x minus 1 times x minus 1 is x minus 1 quantity squared. The next 2 will cancel each other out. Does everybody see that? Because you have a plus and a minus. Don't do it. And now all you have to do is multiply these 2 out. What's 3i times negative 3i? Isn't it 9?
Yep.
It's just a 9. Now can you factor this? How do you factor this? And then add your 9. And simplify. And that's your answer. That's a polynomial that has zeros at 1 plus 3i and 1 minus 3i, and we don't care about the a value. But in the next problem, I want the a value. I want a specific answer. So I purposely wrote the same question, but now I'm adding to it. Now I give you an x and a y value. So what you'll do here now is you're going to take this answer and you're going to write it like this. Now plug a 2 in for x, a 3 in for y. I need that a value. So 3 equals a, 2 squared is 4, minus 2 times 2 is 4, plus 10. Anyone know what a is? This is going to be 10a. So a is 3/10. all you have to do now is go back right up here and put 3/10 here. And just leave your answer. As far as I'm concerned, leave it. And you can distribute that, A value. But just leave it. Okay? All right, example 5. I'm giving you a polynomial with a degree of 4. How many zeros are there with real and imaginary? There's 4. I know there's an imaginary one at 2i. Is there another one? There you go. So if 2i is a 0, you know negative 2i is a 0. So can we write this in factored form so far? Yep. Do you agree? If 2i is a 0, so is negative 2i. How many more are there? We gotta find 2. So what you're gonna do is you are going to multiply this out. You get x squared. The next 2 cancel out and you get plus 4. I did that fast. So in other words, x squared plus 4 is a factor. Goes into x to the 4th minus 5x cubed plus 10x squared minus so forth. This is gonna go into this evenly. So what we need to do is take this, we're gonna do x squared plus 0x plus 4. And you are going to divide this into this. And it better go into it evenly. Otherwise, we made a mistake somewhere. So quickly, we're masters at this now. What do we want to do? We want to get rid of this x to the 4th. So x squared times x squared is x to the 4th. We're going to multiply these 3. So x4, 0x cubed, and 4. 4x squared. Okay, we're going to subtract. Cancel, negative 5x cubed plus 6x squared, bring down negative 20x. Always bring something down. We need to get rid of negative 5x cubed, so we need a negative 5x. This times these 3. Negative 5x cubed, 0x squared, 20 minus 20x. Subtract. This cancels. We get 6x squared, 0x, and bring down your 24. We need a 6. And everything will cancel if you just make sure. 6 times x squared is 6x squared. We have no x, and we have a 24. When you subtract the same thing, you get 0. That's what you want. Because if this goes into this evenly, there should be no remainder. So this is the leftover stuff. So we have x squared plus 4, and our quotient was x squared minus 5x plus 6. We have 2 more zeros hidden in here. What are they? Be careful on this one. Everyone wants to say 6 and 1. It's negative 3 and negative 2, because that multiplies to be a positive 6 and adds to be negative 5. So what are your 4 zeros? This gave us plus and minus 2i. Those were imaginary. Oh my gosh. X equals 3, and x equals 2. Do we have 4 zeros accounted for? Yep, done. This question is from chapter 2. How do you factor this? 2x to the 4th, and you have a negative 4 here. It's a trinomial. Do you guys remember this? I need to FOIL this out so I get a negative 7x. That's going to give you a negative 8 and a 1. Does that work? Does that FOIL right? And we want the zeros. There should be a 0 here. So, do you know what 2 zeros you get here? Without blinking, 2 and negative 2? How about this one? subtract 1, divide by 2, square root. So it's plus or minus root 1/2 I. And can you rationalize it? Square root of 2 over 2I. You guys remember that? In the last one, I know I'm running out of time, this is an old problem. How do you know if this is a factor of this? What do you plug in here to test it using this factor theorem? You're gonna plug a 2. What is 2 to the 6th power? 64? And what's 64 minus 10?
54.
So is x minus 2 a
No.
factor of that? No. If it was, you'd get a 0 remainder. 54 is your remainder.